So from today, we are going to discuss one of the really interesting topics. It's like linear algebra, or sometimes it's called the analytic geometry as well. So in the beginning of the lecture, we are going to do all of this definition. We're going to try to give all of these definitions. So previously we dealt with the equations with just one variable, right? So whether it was the quadratic equation, whether it was the inequality, or whether it was an equation which involves the absolute values and so on. And we drew the solutions using the intervals along just one axis, x-axis, right? So we learn about the open intervals, closed intervals, or infinite intervals, and so on. So from today, we are going to deal with the equations which is going to have two variables, x and y. So as we have defined the domain of the x variable as an x-axis, domain is the source of the values for this variable, okay? We are going to do the same thing for the y. We are going to denote, or we're going to introduce the axis for the y variable as well. So this is going to be called simply as y-axis. So sometimes we're going to call as x-axis as abscissa. So sometimes we call this as ordinate. So I would like to also mention that it is important that you take the notes, because so later on I will let you use the notes in some of the quizzes or in exams, okay? So it's important to take the notes. So what we are going to learn today is we're going to learn about how to define the points on the rectangular coordinates. So how to find the distance between the 2 points, how to define the lines, for example, or something which is called the line segment or the bisector, and so on. So in order to define the points on the rectangular coordinates, we need to know where is the origin, okay? Because so we are going to define the points by just going some distances, some units, and horizontal and vertical direction from the origin. So this intersection of these two axes, x and y, is called the origin of the rectangular coordinates, and we denote this as the O. And whenever you would like to draw some point x, you need to just go some units in the horizontal direction and some units in the vertical direction. So I just would like to write down that this direction is called horizontal, and this direction actually is called the vertical direction. Okay, so any point along the rectangular coordinate system. So this system now is going to be called the rectangular coordinates. And any point on the system is going to be given using so-called two-tuple. So could you please write this down, the meaning of the two-tuple? So the two-tuple is simply the ordered pair of numbers. So it's the two numbers which are written inside the brackets with the commas. Okay, and I would just like to give you some examples of what does it mean, the ordered pair of numbers. So for example, Muhammad Jan, could you please tell me what is your height?
Height? What?
Yes. Boys, height.
I'm
yes. Yes. 100.
165.
65. What is your weight?
62.
62. Okay. What about Babarja?
170.
Okay.
60.
Okay, and so on. Okay, so let's assume that what I would like to do is I would like to record the heights and weights of every student. And in a computer, for example, in C++, for example, I would just record them in vectors, right? And in this vectors, I'm just going to allocate the first position for the height and second position for the weight. It is important because whenever you're mixing up the values, and you, for example, write down 62 and 165, it doesn't mean that the height is 165 and weight is 62 anymore, right? It means that the height is 62 and weight is 165. Okay, it is important that you keep the order. The order of these two numbers is important. So this vector or this two-tuple is different from this one. Okay, they are not the same. So whenever you write down a bunch of numbers all together inside the brackets, it is called a two-tuple. Okay, where the order is important. Every position means something. okay? And you cannot just mix them up. So later on, we are going to introduce 3-tuple for the points in the 3-dimensional space. And in the linear algebra, for example, you're going to deal with the n-dimensional space, and you're going to define the vectors and the points in using n-tuple, okay? So I hope that you've got this idea of the 2-tuple. So now, if you're given this point, x and y, it means that the first coordinate, so the first position of this 2-tuple is going to mean the x coordinate always. And the second position is going to mean the y coordinate always. And whenever you go this x, it means that you need to go x units in the horizontal direction, either to the right if x is positive, either to the left if x is negative. And and then you need to go y units either in the vertical direction, either to the up, either to the down, whether y is positive or negative. So, so sometimes it is very difficult. Okay, so for example, let's do some examples. So this point 4 and 3 means that I went 4 units to the right and 3 units to the up. Or -3 and 2 means that I went 2 units to the left because -3 is x coordinate is negative, and 2 units up. Then I've got -2 and -2, 3 and -3, and so on. And it is really difficult for me to describe the position of those points on those rectangular coordinates. And people have figured out, do you understand this word, figuring out? Figure out. So could you please Google and try to get the translation? So because I use this word expression a lot. So figuring out. So people have figured out that it is much more easier to define, to express, to tell, to describe the position
Hello.
Where is professor?
Internet
Maybe
problem,
internet
guys.
problem.
Zoom soz atardım değil mi?
Sorry, so it was problem with my internet.
Yeah.
Okay, we were discussing about the quadrants. And now it is easier for me to say that a point 4 and 3 is in the first quadrant, or the point with the coordinates -2 and -2 is in the third quadrant. So you will see that it is not just a definition, you will see that it is very important concept, the quadrants, later on when we are going to talk about the trigonometric functions. For now, you just need to understand what makes actually different the first quadrant from the second one. Is actually the signs of the x and y coordinates of the points on those particular quadrants. On the first quadrant, x and y coordinates are positive, right? So x is positive and y is positive. What about in the second quadrant? X is
Negative.
negative. Y is positive, right? What about in
Yeah.
third quadrant?
And
Both
x
of them
and
are
y negative.
Negative.
Okay, both negative. And on the fourth quadrant, x is positive and y is negative. It is very important to keep this in mind. In which quadrants the x's are positive, in which quadrants and y's are positive or negative, okay? So what I would like to now define is the concept of a distance between the 2 points. If you remember, when you would just get one-dimensional space, right, or just 1D, just one axis, it was easy for us to define the distance because if, for example, I need to find the distance between -3 and 1, what we did is we just subtracted those numbers and took an absolute value, right? So now in 2D, we can define the distance very much differently. So in our life, actually, we can also define the distances very much differently. For example, so I live about 2.5 kilometers from from this office, and I can measure the distance between the office and the home, for example, in kilometers. It is going to be equal to 2.5 kilometers. But at the same time, I could just measure the distance in terms of the time. For example, I spend 20 minutes. I mean, distance from my home to this office is 20 minutes. Or I could just measure the distance in terms of the money which I would spend for the taxi. So I live 20,000 soms away from this office, for example, and so on. Okay, so you can measure or you can define. I hope that you understand this word, definition, or define or definition. Okay, so it is important for us to define the distance, and we can do this in many different ways. Okay, so in this course in calculus, we are going to define the distance as an Euclidean distance, or as the length of the line, straight line, which connects the 2 points, whether it is in 2D or in 3D. But later on, you will see that in some other mathematical subjects that distances can be defined differently, and depending on what type of the problems you would like to solve. Okay, so again, the distance for now is the length of the line, the straight line, which connects these 2 points. If you are given 2 points with the coordinates 5 and 4 and 1 and y, how do you have any ideas how we can find the length of this line, or the length of this line segment, by the way?
Pythagoras theorem with
okay, for example, we can use the Pythagoras theorem. Yes. Yeah. So in order to do this, we are going to make, first of all, the triangle, right? And it is easy for us to make the triangle because we can calculate the lengths of those of the sides of the triangle, right? For example, so the distance from the x-axis until here, it's equal to the 1. Until here, it's equal to the 4 because the y coordinate is 4. And obviously, right? Okay, so there is a mistake, obviously, right? And obviously, the height is going to be equal to the difference between the y coordinates. In this case, it's going to be 4 minus 1, which is equal to the 3, right? The same is with the width. So the distance from here until here is equal to the 1. From here until here is equal to the 5. And obviously, the width is going to be equal to the 5 minus 1, which is equal to the 4. The height is equal to the 3, which is the difference between the y coordinates of the 2 points, and width is equal to the 4, which is the difference between the x coordinates. And you can see that it perfectly creates the right angle triangle, right? And there is the Pythagoras theorem, which helps us to calculate the lengths or the hypotenuses of the right angle triangle. So I would just like to remind you this one more time. If you've got the triangle where one of the sides is 90 degrees, right? Then if you are given the length of the 2 sides, A and B, then you can find the longest side, which we call is the hypotenuses, right? Hypotenuses. Using this formula. So the D in the square is going to be equal to the A in the square plus B in the square. Okay, so this is called Pythagoras theorem. So in Uzbek or in Russian, we call this Pythagore. Okay, and in English, please note that it is going to be called as the Pythagoras theorem. So we can use this theorem here, and we can see that the D in the square is going to be equal to the 3 in the square plus 4 in the square. So it's like flip around, right? But it's okay, but because the value is going to be, again, 25, and the D is going to be equal to the 5, okay? Because we need to take only the positive part. So this is how we can find the length of the line segment, which connects the 2 points. Okay. In general, if you are given 2 points with the coordinates x1, y1, x2, y2, okay, we are going to now we are going to derive the formula. So before we do this, I just would like to remind you that we are going to define the points using the capital Latin letters, as you have mentioned already. I denoted A, B. For example, you can denote the P. P1 was the coordinates x1 and y1, and P2 was the coordinates x2 and y2. Oh, by the way, can I write down the P1 is equal to the x1 and y1 in order to denote the point?
What? Sorry.
Is it a valid notation for the point? No, okay.
No.
So this is valid, okay. This is invalid because whenever you write down the equality sign, it means already the vector, not the point, okay. So the vectors are also defined using the two tuples. We're going to discuss about the vectors after the midterm in this course, okay. And the valid notation for the point is whenever you write down the capital Latin letter, then just after that you're going to define or write down the coordinates of that corresponding point. Okay, it's important. So we are going to find the difference of the x coordinates, which is going to be x1 minus x2, right? So we're going to find the coordinates of the difference of the y coordinates, which is y1 minus y2. And their squares, the sum is going to give you the distance in the square, right? Because it's going to give you the lengths of the of the right angle triangle, right? Okay. So here is the formula. So the distance in the square is the difference of the x coordinates in the square plus difference of the y coordinates in the square. Then obviously the d is going to be the square root and of this expression. So let's assume that you were given the 2 points. A was the coordinates -3 and 2, and B was the coordinates 4 and 1. Let's try to find the distance between these 2 points. In order to do this, first of all, I would find a difference of the x coordinates, which is -3 minus 4 in the square, right? Plus the difference of the y coordinates is 2 minus 1 in the square. And this is going to be the distance in the square, okay? And this is going to be distance in the square is equal to the 49 plus 1, which is equal to the 50. And the d is going to be equal to the square root of 50, or you probably can write this as the 5 times square root of 2. Okay, because 50 is 25 times 2, and 25 square root is going to be equal to the 5. Okay, so this is an example of how to find the distances. And it's not so difficult, right? So sometimes I forget usually what is the formula finding the distance, but you need to understand the concept so that you can always derive the formula. Derive the formula. Okay, so the concept of the distance, the concept of the distance has so many applications. For example, to define something which is called the perpendicular bisector. Okay, so could you please tell me what do you understand by line? Could you please tell me what is the line?
Line.
Yes,
It's like it has.
it's not
starting
obviously the animal, right? Yeah, line.
with a like it has starting but no ending.
Oh, actually, it doesn't have the starting and ending points. The line segment has ending and starting point. Okay, so the line is an object. So this is going to be the strict definition, or like mathematical or formal definition. The line is an object which can be obtained by connecting 2 points, okay? Which connects 2 points and can be continued in both of the ways, in both of the directions. For example, I've just got 2 points. I'm just going to connect these 2 points, and I can go until infinity in both of the directions. So that's going to be the line. And the line segment is actually the part of the line between the 2 points, okay? This is going to be line segment. It's important. So we're going to learn how to define the lines using the equations or the line segments with the equations and so on. So the perpendicular bisector is a line which fulfills the 2 conditions. The first one is it splits the line segment between the 2 points A and B exactly to the 2 equal parts. So essentially the length of this part is equal to the x, for example. The length of this part is y, and this x is equal to the y. The lengths are going to be the same. And the second condition is that, as its name, it is going to be perpendicular to this line segment. So actually the angle between the line and the line segment is going to be equal to the 90 degrees. So later on, I hope that you will give enough concepts or enough understandings of all of these processes which are going on in the rectangular coordinate system in order to derive the equation of the perpendicular bisector. But for now, what you need to do is, if you are given some point C, any point, arbitrary point C, with the abstract coordinates X and Y, you need to be able to know whether this point C is lying on this perpendicular bisector or not. Okay, so for example, let's say you are given C. For example, the coordinates of the C might be might be 0 and 2. For example, 0 and 2. I would like to know whether this point C is on the perpendicular bisector or not for those 2 points, A and B. Okay, do you have any ideas how to check this?
Take the points in this X and Y, 0 and 2.
Okay, and then? So you're given 0 and 2. I would like to know whether this is on the bisector or not. You just need to use the concept of the distance. Okay, for example, if I would just find the distance between A and C and B, what do you think? Are they going to be equal?
Yeah.
Yeah, actually, yes. So they're going to be always equal, right? Because so this line is perpendicular, first of all, to the base of the triangle, right? And also it splits exactly to the 2. So that is why any point along this bisector is going to have equal distances to these 2 points A and B. Okay, so if you are given a point, and if you would like to know whether this point is on the bisector, you can just find the 2 distances and check whether they're equal. Okay, and what we are going to do is we're going to do this for any point along this bisector. Okay, and if you do this for any point, you are going to derive the general equation of the bisector. Okay, so let me show you how to do this. So first of all, I would like to find the distance between C and A. So what is the distance between C and A? This example is very important conceptually. It gives you so many feelings and insights about how to work actually in the analytic geometry, so-called field. Okay, so C and A, what is the distance between C and A? So let's say distance in a square. It's going to be x minus 2 in the square plus y minus 3 in the square, right? So the distance between C and B is going to be equal to x plus 2 in the square plus y minus 1. Y, yes, y. Okay, y minus 1 in the square. So if the distances are equal, then their squares are equal as well, right? I mean, this is true. Vice versa might not be true, okay? But in this direction, this is true, okay? So I'm just going to equalize them. So if I would just open this brackets, could you please tell me what is going to be this expression when I open the brackets? X squared
minus 4x and plus 4
plus open this
y
squared.
Yeah, y squared
minus 6 y
minus 6 plus
9.
8.
okay
plus 9
it is equal to, could you please open this one?
X squared
X squared plus
4x
4x
plus
plus
4
4
plus
Plus 4.
y
y
y squared
and minus 2 y and plus 1.
Okay, great. So since they are equal, I can cancel some of the terms, right? We can cancel this and this, this and this, this and this, okay? And let me put all of these terms into this side, okay? In this case, what I will get? 4x plus 4x, it's going to be 8x, right? Minus 2y plus 6y, it's going to be 4y, right? Plus 1 minus 9, it's going to be minus 8.
Professor,
Yes.
Professor,
Yes.
you made a mistake. Look at this, here is minus 4x and you added minus 4x plus 4x, it will be 0.
No, they are in two sides of the equation. So, okay, so let me.
So sorry.
Did you get it?
Yeah, yep, I got it.
Okay, thank you. So 8x because they're in two sides, because whenever this -4 goes to the other side, it's going to be plus 4x. Plus 4y minus 8 is equal to the 0. I'm just going to divide everything to the 4, for example. It's going to be 2x plus y is equal to the 2. Okay? You see, so this is the condition so that the x and y coordinates of any point along this bisector should fulfill. And at the same time, I mean, this is the load, right? Which every point along this line is going to fulfill. Okay, and this is nothing else as the definition of the equation of the line. So whenever I say, hey, what is an equation of the line? I'm just asking you, could you please tell me the load which every point on this line should fulfill? Okay, so this is an equation of the line of the perpendicular bisector, and it has infinitely many solutions. Okay, so today we're going to define what do I mean by saying the solution of this equation with two variables. So let me just give you a couple of examples to give you some insights about what do I mean. So if you just take a point 0 and 2, for example, what do you think? Does this point is lying on this bisector?
It's correct. When we
yes, because if you just substitute x was the 0, right, and y was the 2, it is going to be equal to 2 is equal to the 2. This equation is going to be true, right? Or for example, another point was the coordinates, for example, -1 and 4. Is it on the bisector?
Yes.
Yes, because if you substitute this here, it is going to be again true. Okay, you see, so this equation is going to have infinitely many solutions because you can play with the values of the x and substitute them into the equation and find the values of the y actually. Okay, so any equation I can tell you that with two variables is going to have infinitely many solutions. Okay, in general, there are 3 scenarios of the number of the solutions for the linear equations. It is either has no solution, either has just unique one solution, either it is going to have infinitely many solutions. Any linear equation which has 2 solutions is going to have infinitely many solutions. Okay, cool. So this is how we're going to derive the equation of the bisector in a very easy way, because if you would use geometry, you would spend a lot of time to derive this. Okay, so what we did actually is called analytic geometry. Okay, so the midpoint between the 2 points is going to be found in this way when you're going to simply take the average of the x coordinates and y coordinates of the corresponding points. So let's do this for this example. So it's going to be the midpoint is going to be equal to -2 plus 4 divided to the 2, and 3 minus 2 divided to the 2. It is going to be equal to 1, right? And 1 over 2. Okay, the midpoint between the 2 points can be found by just taking the averages of the 2 coordinates of the points. Okay, so here I would just like to give you a couple of definitions again. So an equation in 2 variables, say x and y, is the statement in which 2 expressions involving x and y in both of the sides of the equation should be true. Since an equation is a statement, it may be true or it may be false depending on the values of the x and y. So whenever the values of the x and y is going to make your equation true, we say that this points or this values are satisfying your equation, or sometimes we call this as a solution of the equation. For example, we derived this equation. We have derived it. Okay, so it is important that you write this, because I mean during the exams, the midterm exam and final exam is going to be the written exam where you need to write down, express your solutions in a written form, and we take care of your English as well. It's important for us. Okay, so we have derived the equation 2x plus y is equal to the 2. Okay, for example, the following 2 tuples 0 and 2 is the solution. Okay, you see, so the solutions now are going to come not just as one number, it is going to come as 2 numbers. Okay, so it is the solution of this equation. Because if you substitute x was the 0, and y was the 2, if you substitute this, it's going to be 2 times the 0 plus 2 is equal to the 2, 2 is equal to the 2, this expression is going to be true, right? This equation is going to be true. In converse, for example, -1 and 4, -1 and 2, let's say, is not the solution, no solution. Because if you substitute this into the equation, it's going to be -2 plus 2 is equal to the 2, 0 is equal to the 2 is false. Okay, so you are given now the equation with two variables. The solutions of this kind of equations are going to be two tuples, okay, the pairs of numbers x and y, okay, and it is going to be a solution if it is going to satisfy your equation. And if I ask you what does it mean that it is satisfying the equation, you say that if you substitute these values into the equation, it is going to be a true statement. Okay, cool. Could you please quickly determine whether these points A and B are lying on the graph of the equation of this line, actually? So this is an equation of the line. So this is the line. So some line, okay? So you are given some point A, and if you would like to know whether A is on the line or not, you just need to substitute its coordinates. It's a very important concept. So over the many courses of my experience, I had so many difficulties of students of understanding this concept. What does it mean, the solution? So that this time I've decided to start with this basic fundamental things, okay? So the x is equal to the 2, y is equal to the 3. You just need to substitute into the equation. It's going to be 2 times the 2 minus 3 is equal to the 6. On the left-hand side, I've got 1. On the right-hand side, 6, which is false. Right? So that is why this point A with the coordinates 2 and 3 is not on the line. Let's do this for the B. So the x is equal to the 2, y is equal to the -2. I'm just going to substitute this into the equation. It's going to be 2 times the 2 minus -2 is equal to the 6. So 6 is equal to the 6, which is true. It means that this point B with the coordinates 2 and -2 is lying on the line. Okay, so you see, so if you are given some points and if you would like to know whether these points are on your line, you just need to substitute this. This is actually the definition of the equation of the line. So the equation of the line is, again, as a law, or it's a map which is going to tell you which constraints, which conditions your points on the graph should fulfill. Okay. So let's discuss about the concept of the line. Okay, so we're going to discuss about the line and many different perspectives. And one of the perspectives which we're going to discuss is how to sketch the graph of the line if you're given an equation. Okay, so you are given, it is important, equation. What you need to do is draw its graph. So sometimes we call the sketch its graph. Any ideas how we can sketch the graph of the line?
Yes, we
You can use the
should
graphical
give
calculator.
x any numbers, for example, 0 and y equal to 3, and like this we should.
You're already describing the steps, right? But can you describe the concept? The bigger concept. The concept is, so if you would like to sketch the equation of the line, you need to find 2 points along this line, and then you can just connect this, right? You already described how to find the 2 points, but the bigger concept is, first of all, is you need to find 2 points along this line and then just connect these 2 points. Okay, this is how you're going to sketch the graph of the line. In order to find the coordinates of the 2 points, you are going to use, for example, this table, right? So as you told, you can just give any value for the x, put this into the equation and find a y value. For example, if you substitute x to be equal to 0, what is going to be y?
3.
3, right? Y is going to be equal to the 3. The first point is going to have the coordinates 0 and 3. This is going to be this point, right?
1.
Okay.
Yeah.
If x is equal to -1, what's going to be y?
1.
1.
1. The second point is going to be -1 and 1. It's going to be here. Then the line is going to connect these 2 points. It's going to be this. Okay. So this is how you can sketch. I mean, it is not necessary to find a third point. 2 points is enough. Okay. So if you are given the equation, this is how you're going to sketch the graph of the equation of the line, at least. Okay. So over this course, we're going to learn how to do this for the quadratic equation or for any other type of the equations. So the inverse question is a little bit difficult. So if you are given 2 points, how to find the equation? Okay, so this is going to be kind of the inverse problem, right? So previously you were given an equation, you can find any point on this line using this equation. You just need to understand that this equation is actually describing you any point. Okay, so instead of just writing down infinitely many points, coordinates of infinitely many points, you're just writing down this in the compact form, just using the equation. And now you're given 2 points, you would like to find the equation. And in order to do this, it appears we need to understand the properties or the components of the line. So any line is going to be given in the form of y is equal to the kx plus b, at least in 2D. Okay, so could you please write this down? So the y is equal to the kx plus b, where k, the meaning of the k is slope. It basically means how much it is sloped. Okay, and the values of the k is basically going from -infinity to the +infinity. It can be any value. And b is going to be the y-intercept. It basically tells you that where exactly on the y-axis your line is crossing it, if it crosses. Okay, if it is not a vertical line. So for example, if this line is crossing this y-axis here, this is going to be the b. Okay, so what I would like to do first of all is I would like to play using an application which is called the GeoGebra, in order to try to understand geometric meaning of the slope and the b. But at the same time, I need to tell you that in Russian, for example, k is naklonность, how much it is naklonное, okay, how much it is sloped. In Uzbek, I think it is going to be how much it is picture. So it's very important. Okay,
It's the meaning of the slope.
Yeah, slope.
In gradus, yeah.
Gradus. Picture. Naklonность.
Yeah, with a tangents
Okay, yeah. So this is the application of the GeoGebra. You can install this, or there is a web version of this, geogebra.com. I would really encourage you to use this for many examples, because it gives you a lot of insights, a lot of understanding of what is going on. Okay, so I would like to define first of all the b, let's say, is equal to the 1, k is equal to the 5. For example, you can just play with many numbers, many values, so you can create the interactive examples as well. Then y is going to be equal to the kx plus b is going to be this line. Okay, so let us make it thicker. Okay, so now you see, so the value of the k is equal to the 5 now, but I can change this. So as I'm changing the value of the k, the slope of the line is changing. You see, the slope, naklonное, of the line is changing. This is what is changing. This is what does this k controls. Okay, so you can play with this. So just like press the play, and you can. This is very interactive example. So just like the values of the k is going to change the slope of the line. Okay, so you see, so it is also important that whenever the k is positive, you can put your left hand on the line. Okay, so this is one way to remember this. And whenever the slope is negative, you can put your right hand. Negative right hand, positive left hand. Okay, so this is what is the slope. At the same time, you see, so this line is crossing the y-axis exactly at the point 1. Okay, because b is 1. And if you change the b, you see, so it is going to change the height of your line. It is going to tell you at which point your line is going to cross with the y-axis. Okay, so this is what b controls. So just using these two parameters of the line, you can define any line. Okay, so the slope or the y-intercept. Okay, and whenever I ask you to find the equation of the line, you just need to find these two things. You can describe any line by just describing its slope and y-intercept. And I hope that you have better understanding of what they mean. Okay, so fortunately for us, there was a formula which gives us, which tells us how to find the slope of any line. So if you're given 2 points, okay, you can find the slope of the line which is passing through these 2 points using this formula, y2 minus y1 divided as x2 minus x2. Easy. So let's try to do this for this example. So let's say you are given these 2 points A and B. I would like to find the slope. It's going to be equal to the 2 minus minus 2 divided to the 4 minus minus 4. Please note that you need to subtract the y coordinates on the numerator, because sometimes students confuse this with the x or y. So y should be on the top, x should be on the bottom. It's going to be equal to the 4 divided to the 8, which is equal to the 1 over 2. Okay, so now we know already one parameter of this equation, right, of this line. It is in the form of y is equal to the 1 over 2x plus b. Okay, so what you need to find is the b. Any ideas how we can find a b?
Yes.
You give values, like in
Give
the previous
values, right?
example.
So
Yeah.
we know that what these 2 points are on the line. It means that if you just substitute this into the equation, this equation should be true, right? It doesn't matter which point you're going to substitute. For example, you can substitute the b point. It's going to be 2 is equal to 1 over 2 times to the 4 plus b. What is the b from here?
0.
0. The same can be done with the second function, with the second point. So minus 2 is equal to the 1 over 2 times the minus 4 plus b. From here, you can also obtain that the b is equal to the 0. Okay, so the y-intercept is going to be equal to the 0. So the general equation of this line is going to be equal to y is equal to the 1 over 2x. Okay, if you're given 2 points, one way to find the equation of the line passing through these 2 points would be to find the slope of the line first of all using the formula, and then just substitute one of the points into this equation and find the y-intercept. But please note that you can find the equation of the line using the system of linear equations or other ways as well. There are like a couple of other ways of finding the equation of the line, but I like this one because it is very important for us to understand the meaning of the slope, because later on we're going to learn about the derivatives, for example, or the rates of changes, and this is the way how we are going to describe the rate of change of something, rate of change of your function. We are going to describe this using the slopes of so-called tangent lines.